Good morning to everyone. We have discussed the fundamentals in functions, arrays, strings so far. We have seen the different string operations, how to assign string values to the given character array, and how to process the strings, and basic operations of strings. For example, string copy, string concatenation, then finding the length of the string. Hope you have gone through all of these previous sessions. Have any doubts up to the topics so far we have discussed? Okay, in this session, first we focus on how to find the prime factorization of the given integer. So please take the next program. Write a C program to find the prime factors of the composite number or prime factors of the given integer. Suppose integer 100 is given. We need to list out its prime factors. What are the prime factors of 100? 2, then 3 no, 4 not, 5, then 10, 6, 7, 8, 9, 10, etc. Right? These are not prime numbers because 100 is 10 into 10. Further, that is 2 square into 5 square, 4 into 25, 100. So only the prime factors which divides 100 are 2 and 5. This is the problem. So how do we check to list out the prime factors of the given integer? That is a problem. So to solve this, we can do in two different ways. I tell you right the two different ways. First one, when you take one integer 100, first method 1. Suppose input 100 is given. Hundreds right prime factors. How do we extract this 2 and 5? Since we know that every integer is divisible by 1 and itself, so we need to start from, for example, have n as 100. J ranges from 2, 3, etc. n by 2, 100 by 2, or simply n by 2. 2, 3, etc. n by 2. We need to check if 2, 3, etc. n by 2 are the factors of the given integer n. This is one step. Second, if, for example, j is a factor, then further check if j is a prime number. In case if j is prime, right, print j as one factor. What is the factor? That is actually the prime factor. So how long we can continue the process? We need to continue the process for j ranges from 2 to n by 2. For j ranges from 2 to n by 2, check if n mod j is equal to 0. If n mod j is equal to 0, then we can check if, for example, is prime, what you need to check? J. If J is a prime factor, then print J as the prime factor. That's all. This is one logic to find out the prime factors of the given integer. So whatever is the number, right, prime number or composite number, right, all prime factors are going to be obtained. In general, right, every composite number can be expressed as the product of its prime factors. So having 17, right, 17, its factor is right only factors are only 1 and 17 since 17 is a prime number. So prime factorization of 17, we expect 17 is equal to just to 17. That's all. So this logic, how it finds the prime factors of the given number, start with the factors range 2 to n by 2. Check if j is a factor of the given number. If it's so, then further check if j is a prime number. Then you can tell j is a prime factor of the given number. So how long j needs to be checked? Over the range of 2 to n by 2, because 100 by 2 50. So at the maximum any number n can have a factor n by 2, right? Even n is one factor, right, that can be checked, right, after the path. So you need to check the divisors from the range 2 to n by 2. So let us implement this logic first. Then I tell you the second logic to find out the prime factors of, right, n in another way. Let us include the header file hash include stdio.h. Then writing a main function into main. Please check, we have already returned a code to find or to check if the given number is prime or not. So we are going to write once again a separate function so that we can call that function inside the main function. We can simplify the task. Here int n, for example, printf dash n, enter the number or enter the integer. Scanf percentage d ampersand n ampersand n. After getting the n, what we have to do? We need to go through a for loop over the range of 2 to n by 2. For example, here I start with for j is equal to 2, j less than or equal to n by 2, j plus plus. Here I am checking first if what we need to check if n mod j is equal to 0. That means if j is a factor of n, then further if we define one function, say is prime of, right, what we need to check j. If j is a prime number, then printf slash d percentage d comma, we need to print, right, j as the prime factor. Then here, right, we need to, right, let us modify the logic, right, after return to 0. Now have a function is prime. For example, We are returning a value. Int e is prime. One parameter is, for example, some x. X is checked for primality, prime number. How do we check if x is a prime number? If 2, because j ranges from 2 to n by 2. Minimum value of j is 2. Checking if x is 2. If x is a 2, then I am returning a value. For example, return 1. Else, to check x as a prime number, here we use a for loop for some j is equal to 0, sorry, j is equal to 2, j less than r equal to, r is a variable I is equal to 2, I less than r equal to x by 2, then I plus plus. We need to devise a logic here. If what is a number to be checked, x is a number to be checked. X mod I is equal to 0, then let's give break. If x mod I is equal to 0 means break. We need to increment or count. We can design a different ways. For example, here else, this is the else part. Here I check one count variable. Int count is equal to 0. Here count plus plus break. Then after the for check if count is equal to 0. What is the meaning? If count is equal to 0, no factors of x is found. So if count is equal to 0, it's a prime number. So if it is a prime, we are returning a value 1. Return 1. Else return, let us return a value 0 to indicate the given number is not prime. Count is equal to 0. Return 1 to check or to indicate the x is prime. Here also return 1 to check if the given number is prime. Given right, we can modify the logic. Okay, here based on count, we have determined if the given number, say x is prime or not. Then declare the prototype. For example, here int is prime, parameter is int, semicolon. Then what else we need? We need to declare the variables. Here I is used in the for loop, say for int I is equal to 2. Then here int n for into j is equal to 2. J less than or equal to n by 2 j plus plus. Let's check the code. What is the file number? Final file number, I think 85. File save CP86 F9. No compile time errors. Control F9, enter the number, say I input a value, say 100, first to check, 2, 5, right? The prime factors are 2, 5. For example, before this, I give a message, int of slash n prime factors of percentage br, comma, n. Now have the output, enter the number, say 1000. Prime factors of 1000 are 2 and 5. Control F9, say 85. Prime factors of 85 are 5 and 17. Control F9, 32601. Prime factors of 32601 are 310867. What happens when we input a number which is a prime number 17? Prime factors of 17 are, right, nothing gets printed. So how do we modify the logic? Control F9. Prime factor, for example, enter the number 31. Prime factors of 31 are. What is missing here? Control F9. Enter the number 2. Prime factors of 2 are. When a number is prime, Control F9. 3. 3 are. Control F9 is 7. Prime factors of 7 are. So anyone tell me how do we modify the logic so that if the number is a prime number, we also expect its prime factors. 7 means prime factors are just 7. 17 means, right, only one prime factor like 7. That's 17. So now tell me how do we modify here? A single executable statement. Simple logic to be modified. Can you find it? 25, 5, correct. Control F9, 64, multiples of 2, 2 power 6, 64, only 2 gets printed. Control F9, 243, exponent of 3, right? 3 gets printed. Control F9, 97. 97 is a prime number. So we need to have the prime factors of prime factor of 97 is 97. What is missing in this logic, or how do we modify the code to get the correct result and input n is a prime number? Anyone please? Anyone? Vignesh, Saravanakumar, Meghavarshini, Balaji, Vasudhaji,
Yes, sir.
any idea?
Can you repeat the question, sir?
You are not getting me. Control F9, enter the number say 12. Prime factors of 12 are 2 and 3. This is correct. Because
Okay, sir.
4 into 3, 4 is further factorized to 2 square into 3. So 2 square into 3. So please see here so that you will get clear understanding. Again,
Sir, if it is
since
a prime number instead of n by 2, we should do it till n to check it if it is a prime number, sir.
yeah, so what is the logic here? Or what we need to make? 2 square into 3. In this right, only 2 and 3 are prime factors. This 2 is the exponent. So 2 and 3 are output. My question is 17. 17 is simply right 17, right? So prime factor of 17 is 17 since 17 is a prime number. So how do we modify the code? I ask you, right, what is the change to be made in this program? Vasudha ji, he has said finally.
Yes, sir.
Yes.
J lesser than or equal to n, sir, not n by 2. Because if
Okay,
the number is prime, half the way if we do it, we will not know it, no, sir.
very good. But if you change j less than or equal to n, fine, no problem. But unexpectedly, you will be checking the divisors of n over the range from n by 2 plus 1, n by 2 plus 2, n by 2 plus 3, etc. Just n minus 1. Hope you understand. Since the range is 2 to n by 2 here, j range is 2 to n by 2. As you said, yes, we need to check in this range 2, 3, 4, etc. n by 2. After n by 2, we have n by 2 plus 1, n by 2
Or
plus
after
2.
n by 2, till then there is no factor, then directly we can declare it as a prime number and itself will be a factor.
Okay, how can we check right if n is a prime number? So for that right, what we have to do, we need not check in this range, not necessary. N by 2 plus 1, n by 2 plus 2, etc. n minus 1. Up to this not necessary. Since there is no n, right, have these factors. So n right can have, right, n is the factor, sure. So n is checked for primality. That is the question. So clearly after the for loop, shall we call is prime of what is the actual parameter to be put here. We need to check one number as a prime or not. What is that number? After the for loop, 2 to n by 2 are completely checked here. N by 2 plus 1 to
The
n
number
minus 1.
itself, sir.
Yeah, very good. The number itself. So n by 2 plus 1 to n minus 1 need not be checked. N needs to be checked. This is the logic. So check for this n explicitly. This is required. So we need to call right the number itself is prime of n. I think n has not been updated right in the for loop. So checking this right n again for primality. Control F9. Enter the number 17. Prime factors of 17. What happens? Prime factors of 17 are 17 is expected. So E is prime n. Again, right? Control through right this statement because function is returning a value. When it returns, the return value should be processed. So I remove this shift delete. Check if E is prime of what is that number? N. Print a percentage D. This J is replaced by N. That's all. Control F9. Enter the number 17. Prime factors of 17 are 17. Control F9. Say 59. Prime factors of 15 are 59. Control F9. Enter the number 2. Prime factors of 2 are 2. Control F9. Enter the number 5. Prime factors of 5 are 5. So this is one logic, one method to find the prime factors of the given number. Have any doubts in this method? Even you can write a different logic, right, to check if the given number is prime or not. This one, without count also, right, you can modify the logic. That is not an issue. Have any doubts in this logic? Shall we move on to the second one? Okay, second method. Method 2. Suppose take the same integer 100. How do we find the prime factorization? 10th standard CBSE, right? Maths. Please take the reference. 100 is divided by 2, we get 50. Then 50 is again checked for the first prime factor 2. 50 by 2, 25. So how long we need to continue this process? This is the iterative process. Iterative process. This iterative process of divide by 2. This is divide by 2. Should be continued until this n becomes odd number. This is odd number. So when n becomes odd number, that means n is updated by 2. N is equal to n by 2. Repeated operations until n becomes odd. So when n becomes odd, what we have to do? We need to check for the next prime factor. Normally 2, 3, 5, 7, then 9 will not be checked, right? 11, 13, 15 will not be, then 17, 19. These are the prime factors. So repeated division by 2 results in one odd number. Then the next prime factor to be checked are next prime factors a prime factor to be checked is 3. So dividing by 3 not possible. Next, after that you need to check for 5. In case this is divisible by 3, continue the operations, right? Repeatedly, right? Divide by 3. N is equal to n by 3. This we need to perform. N is equal to n by 3, n by 5, n by 7, n by 11, etc. So 3 not possible, 5 will get 5. 5 into 5 at 25. Then this number, how long we need to continue the process? We have some specific criterion. Finally, right, we can reach one number. That number, right, should be less than or equal to square root of this number. This is one method. So taking the square root of 100, we'll get a value, right? Positive root, right? 10. So until this number is, or you need to continue the range, right? Or 2 to 2, 3, 5, 7, etc. up to square root of n. You need to check. So these are the factors to be continually checked, so that you need to print the corresponding factor as a prime factor. Finally, right, you need to check if after the update of n, if n is greater than 2, if n is greater than or 2, right, just to print the value of n. So in this case, say 1723, right? 1723, right? Will not have any factors other than the given number. 2, 3, 5, 7, 11, right? Will not divide. So when n is greater than 2, after these computational steps, you need to print the value of n. This is another method to find out all the prime factors of or simply the prime factorization of the given number. For example, we can output the message 100 is equal to 2 into 2 into 5 into 5. Further right, you can extend the logic in exponent form. We can write this is 2 square into 5 square. Now we are trying to design the logic right to output in this format. 100 is equal to 2 into 2 into 5 into 5. Previously given the number 100, just we output 2 and 5 are the factors of 100. 2 and 5 are the prime factors of 100. In this example or in this method, we do like to display the prime factors of 100 as 2 into 2 and 5 that comprises further 2 into 2 into 5 into 5. Understand? Now let me modify the same code. uh, I rename the file save as CP87 to find the prime factors of the given integer. Here I do not want to write separate prime function. I remove this. Into main, enter the numbers scanner percentage d ampersand f. Print of prime factors of percentage d or later right I modify this printf statement. Now I remove completely these two control logic and function definition is completely removed. Control shift delete. Okay. Now have a look into write our logic. As usual, right? First we need to check if 2 is the prime factor of the given number. If it's so, then again check if 2 is a prime factor. So until 2 will not become a prime factor, we need to repeatedly perform the operations. So for that, right, just to think of this scenario, 100 by 2, then 50 by 2, 25. 100 by 2, 100 is divisible by 2, so 2 is printed. Then the resultant value 50, 50 is divisible by 2, so 2 is printed. So how do we write the code here? Here I write after this print while n greater than 0, do not write the code, right? Let's modify it again. If n mod 2 is equal to 0, printf I write first percentage d. Let me write slash d percentage d, comma 2 because 2 is the factor. Then I need to divide this n by 2. N is equal to n by 2. If n mod 2 is equal to 0, I print a value of right say 2. Then n is further divided by 2. N is equal to n by 2. So how long we are continuing this process? Until n reaches the odd integer. So further I modify the code here. Please understand. Printf slash the percentage d 2 or 2 is printed. Then n is subdivided by 2. N is equal to n by 2. In case I write here is Else, if n mod 2 is not equal to 0, that means n is an add integer, simply I give break. Break right now, what happens? Break exits from the while loop. So the given number n is subsequently divided by 2 until n becomes the add integer. Say take an value n, take n as 100, 100 greater than 0. First what happens? 100 mod 2 is equal to 0. Yes, 100 mod 2 is 0. So 2 is printed. This logic. 100 mod 2 is 0, so 2 is printed. Then n gets updated to n by 2. So n becomes this 50. Then 50 is checked for the divisor 2. While, right, 50 greater than 0. 50 mod 2 is equal to 0. So again, this 2 is output. This 2 is output. Then 50 is equal to 50 by 2. That is n is equal to n by 2. N is 50 by 2, 25. N is 25. Then control checks in the while loop. 25 greater than 0, yes, condition is true. 25 mod is equal to 0, condition is false. So control comes out of else part, right? Else part. Condition false means break. Break right forces the control to come out of while loop. So current value of n is 25. So we have reached this place, n is 25. So 25 is further checked for the factors from the range 3. That means 3, 5, 7. In this case, what we have to do? We need to increment, right? After 3, next number to be checked as 5. Then after 5, next number to be checked, right, as 7. Then 7 after, right, 11. But 11, right, we cannot directly control. So it goes like updating the factor by 2. So 3, 5, 7, 9, etc. Right, this way it goes. But 9, right, there is no possibility because already, right, 3 divides, so that no execution will be taken, but no effect will be. So remaining factors checking process 3, 5, 7, 11, 13, etc. How long we need to compute up to, right, reach a value square root of n. So only these factors are to be checked for a prime factorization. So I control through a for loop for j is equal to j starts at 3, j is equal to 3, j j is equal to 3, j less than or equal to square root of n. So include a header file math.h square root of n. Then j is equal to j plus 2. J gets updated by adding the integer 2. J is equal to j plus 2. Here also we are finding the same logic. What is the logic? This one. If n mod j is equal to 0, here I write printf slash p percentage d comma j as the factor prime factor, then n gets updated to n is equal to n by j. Since j is a factor, n gets updated. The condition fails, right, should not leave from the for loop. So else break this should be avoided because the next value of j that should be checked for. If n mod j is equal to 0, printf slash p percentage it is j, then n is equal to n by j. After that, j gets incremented by 2. J is equal to j plus 2. Now, okay, this one. After this part, here, check the value of n. If n is greater than 2, n is greater than 2, then printf uh, slash t percentage t comma n when n itself a prime number. This if conditional test will be true. Now let us check the code. F2, F9 does include the header file. Hash include math.h. Let us check if we have correctly implemented. Otherwise, we need to revise the logic, revise its implementation. One more error. One J. J has not been declared here. For into J is equal to 3. F9. Okay. Control F9. Enter the number 100. Prime factors of 100 are 2255. That means we are writing 100 as a 2 into 2 into 5 into 5. So in this, let me modify the printf statement. Prime factorization of percentage d is slash n. I write printf slash n percentage d is equal to here we need to make a clear statement. First, let us run the code. Formatting rate we do it later. So 1000 is equal to, right, that we need to check, uh, comma percentage d, right, n. Control F9. Enter the number 1000. 1000 is equal to 2 into 2 into 2 into 5 into, unnecessarily we have this 25, right? So this is incorrect result. Control F9, enter the number 100. 2 into 2 into 5 into 5, right? That's that into, right? That we can later make in a printf statement. First, let us check if the code works correctly. 100, this is okay. Control F9, enter the number 90. 90, right? 2 into 3 into 15. 15 again problem. So what happens? 15, right? That should be factorized as 5 into 3. So we are getting the incorrect result. How do we modify the logic? Any idea? N greater than 0. Let's have a trace for this 90. 90 mod 2 is equal to 0. So first 2 is printed. Yes, 90 mod 2. Then n gets updated to n by 2. N becomes 45. Okay, n becomes 45. Then 45 mod 2 is equal to 0. Condition false. So control comes out of this while. No problem. Next check for JS3. Current n is 45. What we have to do? 45. This is 45. 45 mod 3 is equal to 0. Yes. 45 is divisible by 3. Printf class the percentage it is j. J is 3. So second right factor. 3 gets printed. Then n is equal to n by j. What is current n? Current n is 45 divided by j. 45 by 3, n becomes 15. So new value of n is 15. Then it checks for next value of j. Next value of j is 4. But have a look into right our calculation. Suppose 25. 5 into 5, 25. Then this resultant value 5 is again checked for 5. So how we have computed the iterative process of dividing by 2. Likewise, iterative process of dividing by 3, iterative process of dividing by 5, iterative process of dividing by 7. This should be implemented carefully. Since right once it reaches a value 15, 15 that should be checked further for the same division. What is the factor? 3 should be checked. So how do we modify the logic? Iterative process is skipped right in our logic. We need to modify a little bit in the if n mod j is equal to 0, printf slash p percentage d. Up to right 3, okay. 45, 45 by 3, right? 15. 15 is again checked for the factor 3 until right no factor of 3 is found, or until 3 is until right finding a new factor right other than 3. How to modify the for loop? Currently this n, what happens? N is equal to n by j. What is the updated value of n? 45 by 3, 15. Am I right? This place n is 15. Next 15 is checked for the same j. So shall I modify instead of this if I put while, sorry, what happens? While n mod j is equal to 0, 45 mod 3 equal to 0 condition is true. 3 is printed. 45 by 3, 15. N is 15. Then current n, this is 15. 15 mod j, current j is 3. 15 mod 3 is equal to 0. So we expect a value 3 again here. 15 by 3, right? N becomes 5, right? N becomes 5. Then next stage 5 mod 3, condition false, control comes out of while. Then j reaches j plus 2, j becomes 3 plus 2, 5. 5 mod 5 is equal to 0, 5 is printed. Then n by j, 5 by j, n becomes 1. 1 mod j, right? 1 mod j is not equal to 0. So this proceeds further. So simply I removed the if conditional part into a while part. Let's rerun the code by giving the input 90. 5, save, control F9. The input number is 90. 2335. In between write multiplication. We make it later. Control F9. Enter the number 1000. 222555. Okay. Let us check for some other number. Say 6789. 33173. Having the prime number, right? Say 251. Prime number 251. Okay. Control F9. 37. Prime number 37 is 37. Control F9. 200. 2 into 2 into 2 into 5 into 5. That means 2 power 3, 8. 5 square, right? 25. 8 into 25 is 200. So in between, write this multiplication that you need to write carefully, write one symbol. For example, uh, I write x, here also x. Finally write x not required. So let's check unexpectedly write one x may output. We can control through the logic. Control F9. Enter the number 1000. 1000 is 2 into 2 into 2 into 5 into 5 into. Finally write 1 5 into. Alright. That's unnecessarily coming. So here, sorry, printer percentage d, percentage d, simply percentage d, F2, control F9, enter the number 1200. 1200 is equal to, it's equal to 2 into 2 into 2 into 2 into 3 into 5 into 5 into, unexpectedly right, 1 into mark right comes at the end. 45, the logic, say 2000. Okay, prime factors are correctly printed. I put 100, 2 into 2 into 5 into 5, okay. Then control F9, 171, not a prime number, 3 into 3 into 90. It's coming correct. Control F9, say 17, 17 is 7. Only thing you need to make small change so that the final right multiplication that can be eliminated. Have any doubts in this example? 250, right? Check 2 into, right, 5 into 5 into 5. So 5 power 3, 125, or 2 into 125, or 250. So we have represented the given composite number, right, in the prime factorization. So every composite, you might have studied in 10th standard mathematics. Every composite number, right, can be factorized, right, with respect to prime factorization. Uniquely, only, right, one prime factorization or unique representation is there. So 2 into 5 power 3, writing 250 is equal to 2 into 5 power 3. This 2 and 5 are the prime factors of 250. 5 power 3, 125 into 2, 250. Only 2 and 3 are prime factors. So when the prime factors are represented in the ascending order like this, only the unique representation is this 2 into 5 power 3. Instead of this 2 and 5 or 2 5 is exponent 3, we cannot have any other right representation. That's what every composite number is uniquely right factorized so that the factors are prime factors. Have any doubts in this example? Understand these two methods? Have any doubts?
No doubt, sir. Sir,
Yes.
I wrote a code for this on my own, sir, but I'm getting a lot of errors, sir. Can I send it to you in the email, sir?
Okay, send it. We also check it right during the lab session, Friday lab session. You need to do one thing, yeah. So whatever you are writing, yeah, you need to do the trace. Hopefully, right, you understood that. How I have modified this if into y. Actually, right, first I used the if by giving one input value, right? Say I think 90. We missed right something. The iteration after reaching a value, say 15. 15 should be again checked for 3. That we have missed. Repeated iteration, right? That is missed. So doing this trace only we can find out what errors, logical errors are there in the code. So here even right I can continue j less than or equal to square root of n or j less than or equal to n to minimize the number of operations. It is enough for us to control the factors range change in between the 3 to the square root of n. So do one thing, you need to do the trace right logically, whatever the code you are return, do the trace here, then we can easily modify the logic. Even here this while n greater than 0 and if I have used, this could also be modified while n greater than 0, right? Try to modify this one, right? Removing this equals while n mod 2 is equal to 0. Print of right n is equal to n by 2. Then inside the while, right, you can check if n mod 2 not equal to 0, try to break. Likewise, you try to optimize the code. So this is the method of finding the prime factorization of the given number. Next, we need to focus on further operations on arrays. So given the one-dimensional array, we need to think of sorting the given elements in ascending order, sorting the elements in the reverse order, finding the maximum, minimum element, and how do we split the given array into two subarrays. Suppose an array A consists of 50 elements. We can decompose the array A into two subarrays or two arrays. For example, one array, right, we can move the elements, integers, right, positive integers into one array, negative integers into another array. That means we are splitting the array into two subarrays. Or we can find some other logic, right, odd numbers, right, odd integers can be moved to one array, even integers can be moved to another array. That is array split operation. Then we can insert the element right at a particular position. Suppose input array is 1, 2, 3, 4, 5. 5 elements are there. At the second position, we need to insert a new element. So when we insert a new element at the jth position, what happens? The element at the jth position moves to the j plus 1 position. So subsequently, all elements, right, are moving to the successive positions. That is array insertion. Array deletion. Input array is 10, 20, 30. The second element 20 is deleted. Right? We cannot delete the memory location. Instead, when 20 is deleted, right, we can ignore right the 20 or simply the element right 30 is moved to the previous location. We need to print only the first two locations, 10 and 20. That is array deletion problem. Likewise, we can remove completely the duplicate elements in the given array. 1, 1, 1, 1, 2, 3, 5. The number 1 is repeated several times. So after removing the duplicates in this case, output is 1, 2, 5. 1, 1, 1, 2, 2, 2, 2, 5, 5, 5, 5, 7, 7, 7. Several elements are repeated several times. We need to output only one time. For example, 1, 2, 5, 7, 1, 3, 5, 7, like that. So the numbers would appear only once in the outcome. When it gets repeated, we need to ignore how many times the number is going to be repeated. Only one time the outcomes will be returned. So this is the logic, right? To find out the removal of array elements. We try to implement that logic right in the next session. Thank
Thank you, sir.